In this video, I'm going to talk about how to create the tool paths to manufacture this part here. This is from our 2019 robot, part of the elevator. And so it's made from box tubing, 1 inch by 1 inch by 1/8 of an inch thick. And the first thing that we're going to do is create a setup for machining this face here. And this will be the first setup. So once you have the part open, go to Setup, and the first thing that we want to do is set up the coordinate system, specifically the work coordinate system. This back left corner is where we want the origin to be, and this will be held in a vise. This will be the x-axis here, and so right now it's set at stock box point. I recommend just the model box point in case the stock is a little bit larger. And we're going to click this part right here. And then under orientation, I prefer the select z-axis and x-axis. And basically, z-axis is highlighted right now. And so if you select this plane, the z-axis will be perpendicular to that plane. And that's what we want. But we want the x-axis along this line. Right now, the x-axis is along this direction. So we're going to go here on x-axis, click here. Now the x-axis is pointing in the wrong direction, so I just need to flip it. And so this is basically what we want, where the x-axis is to the right here, the z-axis is up, and the y-axis is along this line. Then I'm going to go to stock. You can do a relative size box or a fixed size box. I'm going to show you just a fixed size box where the length of the tube is a little bit, length of the stock is a little bit longer than the length of the tube. Maybe we could go 7.5 inches, but the model position in the X, we're going to offset from the negative X, and the offset is 0. So basically we have a little bit of extra material hanging off the side here. And then the Y and Z heights are 1 inch, which represent the size of the actual tubing that we're using. So now the setup is created, and we can go OK. This says setup 2 because I was doing some other things before, and so we can change the name to setup 1, just so the manufacturers later know that this is the first setup that we'll use. Now, these holes here have a diameter of 0.196. We could measure that by going to inspect and hitting measure. And you can collect the hole, and the diameter is 0.196 inches. This is the standard hole size that we use for many of the holes in our robot. Basically, it's the clearance hole for a number 10 screw, and it also fits a 3/16 inch rivet. So going to cam, we're going to hit drill. The first thing that we're going to do is select the tool. The tool, we're going to machine this on the Tormach mill. So go to Tormach mill. Tool 16 is devoted to 0.196, and we can then go select. Then on the geometry, we can click each individual hole, or to save a little bit of time, if you click select same diameter and then click hole, and you click one of them, it will collect all the holes. It will select all the holes of the same diameter. Then on heights, we want to go to the correct depth. So the height, the whole bottom, we want to make sure that the whole bottom is not going all the way through the tube, and it's not. But we want to make sure that we go all the way through. Not just the tip goes to, not just to the tip of the drill bit hits the bottom, but we want to make sure that that goes through. And then typically I have a little bit of breakthrough, maybe about 15 thousandths. And so that was 0.015, not 0.15, so 15 thousandths. I recommend just to give a visual look at where the drill bit tip is going, to make sure that we are going through. So here's the tip, here's the body of the drill bit, and you can see that we have um, gone through that extra 15 thousandths. Since we're just drilling into air, you can go a little bit more if you would like. It's a pain when you don't go deep enough because then we have to go back to the drill press and fix that later. So make sure that you're going deep enough there. And then under cycle, this is just the type of drill operation that we want. And there's many different types depending on the depths of the hole. This is a very shallow hole in 1/8 inch material. So just drilling and wrap it out is fine. It'll just kind of punch through and lift out. But there's many other types, and I recommend you look at the different options for drilling. So then we can go, okay, and the drilling operation set. The next thing we need to do is cut the end, this right end to length, because if you look at the stock is cut longer, and so we need to cut the end to length. The left end here has already been faced, and it is square, but the right end is not. And so to do this, we're going to click 2D contour, and we're going to select the end, the tool first. And so here on tool, go to Tormach Mill Tools. Tool number 4 is the tool that we'll typically be using for most of our contours. This is a 1/4 inch flat end mill with 3 flutes. It's made for aluminum, and it's a stub length, meaning it's much shorter than the standard length. And we are going to hit select. And the first thing I want you to do here is change the feed rate and dial it down to 1/1000th per tooth instead of 2/1000ths of an inch per tooth. What we're really doing in this operation is doing a full width slot cut, and we're cutting the full width of the end mill as we cut through, and we want to make sure that we slow the end mill down so that it cuts at the correct speed and doesn't break the end mill. These speeds are preset in the tool library for aluminum, but typically it's meant for cuts that aren't slot cuts. And so whenever doing a slot cut like this, I recommend that you just half the feed per tooth under the tool. Okay, just going through on the geometry. We're selecting this end. There's a couple ways to select the end. I think the easiest way is just to hit the Alt key and click the button, and that selects that geometry. I'm going to deselect it to show you a different way. So I'm going to clear the selections. If you just left click, it selects the entire perimeter. But if you left click again, then you can go here and just do this open contour and then hit accept. And that gives you the end as well. So the Alt left click or the left click again, and then select open contour will give you this. And we're just cutting this end here. Now on depths, on the height, notice it says selected contours. So that is the very top. That's the bottom height currently, and we want to go lower than that. And so the bottom offset, I want to go more than 1/8 of an inch, usually about 15 to 25 thousandths more. And so if I go negative 0.14 inches, that gives me basically 15 thou extra of clearance as I cut through there, because the depth is negative 0.125 to this point at the bottom of the tubing, and then we want to go just a little bit deeper. Going here to passes, we don't need to do any multiple passes or anything like that. We're going to cut this in a single pass, and so we don't need to worry about that tab. But under linking parameters, there is something that I want to change, and that's the lead in and the lead out. Basically, I want the end mill to dive into air and have plenty of clearance before it hits the material. So the end mill, I want the end mill to dive into air to full depth, make a straight cut, and then exit. And so I took out the angled lead in, and I also increased the linear lead in distance. And we can hit OK so you can kind of see what that looks like. And the nice thing is if it doesn't do what we want, we can always go back and change. But this shows you kind of the path. If we give a side view here, you can see that the end mill is going to dive into air, cut through the material, cut a little bit deeper, again, that extra 15 thousandths of an inch, and then come back up. We can actually simulate that. If I hit here, go to simulate, and hit play, you can see the end mill coming down, going up. Um, if we have an isometric view, you can see the slot cut that the actual end mill is doing. I understand that the stock is hollow and the stock here represented isn't. It's not a big deal, but it's just something to be aware of. Okay, so now we're really done with setup one. We've done the drilling operation, we've done the contour. Sometimes we choose an operation to put chamfers on all the holes, and I'll show that in a later lesson, but not this one. So now that we've done setup one, we now want to do setup two, which is this side. Now, setup two needs a different coordinate system, but we're still doing very similar things. We're drilling these two holes, and we're going to be cutting this in. What I typically do is orbit the part. F4 is the hotkey to bring up the orbit, or you can go over here and do free orbit here. So I orbit the part, noting that this is now my new coordinate system choice back here, where the z-axis goes up, the x-axis goes here, and the y-axis goes here. But since the setup is pretty much the same, here's a kind of a shortcut that I do is I right click and I go duplicate, and it creates a new setup, and I'm going to rename it to setup 2. And then I'm going to double click on the setup and choose a new coordinate system. And basically, the only thing I really need to change is this model box point. And so I'm going to go here and select this corner. And then I need to go and change the z-axis to be up, and then we have the x-axis there. So I have that now complete. Now the drilling operations are copied from the previous side. So I'm going to double click here and go to geometry and just clear that old geometry. And then I can click these hole faces, and I'm done with the holes. And then for the contour, kind of the same thing. We clear the old geometry, so double click on that. Notice it has the old geometry, and so going to the geometry here, clear the old side, and then on this face right here, this edge, I'm going to go Alt click and hit OK. And we can simulate that whole operation or that whole setup. You can see that we're drilling and then switch to the 1/4 inch end mill, done. All the settings and stuff are the same, the depths, etc. So we saved a lot of time just by doing that duplication. Now for the next side, there isn't drilling. You could duplicate and just delete the drilling operation. We could do that. I'm just going to start from scratch. So the first thing is I'm going to go setup, and I'm going to select this corner. I'm going to go to select z-axis, which is here, and then the x-axis along this line here, and I need to flip it. I have it on stock box point. It really doesn't matter in this case if the stock and the model are the same size. In some cases, the stock is much bigger, so you want to definitely use the model box point. Now going to the stock, since I didn't copy the previous setup, I'm going to go back to fixed size box, change it to 7.5 inches. On the model position, I'm going to offset from the -x and change the offset amount to 0. And then the Y and the Z are the same at 1 inch. And so now that's set up. So you can see you save a little bit of time by copying the previous operation. So now I'm going to hit OK. So now my setup's complete. Now I need to actually do the cutouts. These pockets, we are going to use what's called a 2D adaptive operation. And an adaptive operation, as you can see, it basically uses an optimized toolpath to minimize direction changes and or abrupt direction changes. And it basically uses an optimized path to clear out the material as quickly as possible. And so it's a what we call a roughing operation. It doesn't leave a really nice edge, so we're going to have to come back with a nice contour to clean that up later. So we're going to hit 2D adaptive, and then the tool that we're going to use is the tool 4 that's already selected. First thing I want to do is speed this feed per tooth back up to its original setting at 2 thousandths of an inch of feed per tooth. In fact, we can go faster. If you look at the manufacturer settings, I have these up, the manufacturer settings for aluminum for a 1/4 inch end mill, we can go up to 3 thousandths of an inch per tooth. And on the big Haas mill, I typically do that. On the Tormach, the reason why I go a little bit slower is that sometimes we have coolant issues and we don't get enough clearance of all the chips out of the way when we're cutting. And so I typically slow that down just a little bit. And so that's why it's set at 2 thousandths of an inch per tooth on the default setting. Okay, now we're going to go to geometry. We're going to select these two pockets. Make sure that you have the correct pocket before you click. We just want this perimeter here, and we want this perimeter here. And then we can go to the next tab. And the next tab is the bottom height. Basically, again, I want to go a little bit deeper than the thickness of the material itself. So we'll go negative 0.14, which is an additional 15 thousandths of depth. And then we can go to the next tab, which is passes. Under passes, there's two things that we're going to change. First is the stock to leave. The radial stock to leave is in the width, and typically I like to leave about 10 thousandths of an inch or 0.01. And again, you can hover over things to see what it means on radial stock to leave. It's how much material is left in the radial direction. Now, axial stock to leave is actually the depth. We do not want to leave any axial stock, and so I'm going to change that to 0. I want to make sure that I'm going the full depth. I also recommend smoothing at 1,000th of an inch. You can read what that means, but basically it saves lines of code and it lets the machine move in a more smooth path at the expense of a little bit of accuracy, but we're within the accuracy of 1/1000th of an inch, which is plenty. Okay, and then finally on linking, um, we are going to keep the default settings, but I just wanted you to see that we have this helical ramp set at default. And so we'd never want to dive into material vertically with an end mill, never. And so we have this ramped helical entrance into the aluminum, and that really extends the life of the tool. If you just dive into it, you typically will chip the corners of the teeth of the end mill, and we don't want to do that. And so that's why we have this ramp. So now hitting OK, we can see what it looks like after it generates. It takes a moment. We can highlight it, and we can see this helical ramp, and then it cleans that out. Now, we've left 10 thousandths of an inch in the radial direction, so we now need to go back and clean up the perimeter. Instead of just doing a new contour operation, we're going to derive an operation off of this one. And I'm going to show you how to do that. We're going to right click here. We're going to go create derived operation. We're going to go to 2D milling, and we're going to go 2D contour, which is just a contour path. The reason why I did that is if we create a derived operation, it automatically keeps the same tool, it keeps the same geometry, and it keeps the same depth for us. And so it saves all that time from having to do all of those things. So all we really need to do is look at the last two tabs. Here, we are just cutting around. We really don't have to do an extra finish pass. When I'm doing bearing holes, I do that. These are just clearance holes for tools to get in, and so I don't really care about making sure that the actual size is within a very tight tolerances. And so we'd only really do like a repeat finishing pass on a bearing hole, so we don't need to worry about that. And on linking parameters, basically there's already set a little lead in, a 90-degree angle lead in with a certain radius, 25 thou. And so we don't have to do anything there either. So in fact, there's no settings we really have to change. Hitting OK will let you kind of see what is going to happen. And I'll rotate so you can kind of see. The end mill dives down, but now there's no material there because it's already been cut out with the adaptive. Has a lead in, kind of, and then arcs around. Will cut around, and then it will lead out, go up, and then go to the next pocket. And the final thing that we need to do is just this end cut here. And I think you can actually just copy this end cut here, and we'll see if we can do this. We're going to right click. I'm going to go duplicate, and then I'm just going to drag this to the next operation. Now, the one thing that I have to do is change the geometry because I'm on the wrong edge. So double clicking here, going to geometry, deselect or clear the contour, and then go here, Alt left click, and that gives us that line. So now we have 3 of the 4 operations done. Now on the fourth setup, you might not think that there's anything to do, but we still need to cut this end to length. And so what I'm going to do is go up to the setup 3. I'm going to right click and go copy here or duplicate, and then change that name to setup 4. We don't have an adaptive clearing, and we don't have this 2D contour to worry about, so I'm going to right click and delete those. And then finally, all I need to do is just change the geometry here. So double clicking here, and go to the geometry, clear the previous contour, and then on this edge here, Alt left click, gives it Alt left click. Let's see if I can get it. I'm not sure what the problem is. Oh, what the problem is I haven't set the coordinate system. And so I need to go back, and I'm just going to go cancel here. Even though I've copied the setup, I haven't set the new coordinate system. And so that is the problem that I have. So going here, I'm going to go to model box point and click this corner. Make sure that the z-axis is perpendicular to this plane and that the x-axis is along this line, which it now is. So now I can go OK. And then going back to that setup, we need to clear the selection and select this edge right here. So Alt left click. Now it shows up. So we can go OK. So we are now complete with the operations. I recommend that you play through each of them so you can kind of see what they look like. So we can go to setup 1 and we can go to simulate, and you can hit play here and watch what happens. If it's a really long simulation, you can skip to the next operation within that setup by clicking this button here. But these are really short ones. So you can see that it drilled the holes and it did that cut. And so then we can look at setup 2 and we can simulate. It's always a good idea to play through the simulations because what you see on the screen is what's going to happen at the machine, and you don't want any surprises. And so take that extra minute, double check everything so that you get the results that you want. So simulating setup 3, which is the adaptive, we have the helical entry into the material, And then we do this adaptive clearing where it clears out the material. And then it goes to the next pocket. And then after it finishes that adaptive clearing, it comes back with a finish pass, basically that contour, and cleans up that 10 thousandths of an inch that we left behind from before. And then finally we come back and do the end cut. Again, this end cut is a slot cut, and we always want to make sure we slow the tool down when doing that so we don't break it. All right, that is how we can create the different tool paths for this part. Now, when you want to actually create the G code, what you would do is we'd create, for our case, we'd create 4 different files, one for each setup. And so we kind of click setup 1, we would go to post process. Since we are machining this on the Tormach mill, we're going to change the drop down from the Haas, and we're going to look for Tormach Path Pilot, and this creates the correct G code for that machine. And so we would go here. You would give the part program a name or a number. On the Tormach, you can give it a name. On the Haas, it likes a number, so we can just give it a name. We could give it the name of the part is often what we do. So alpha lift, cart, crossbeam, really long name here, top. And what we typically do is underscore, and then we just type in like op1 for the first operation or the first setup. And then you would go post, and that would create the G code that you could save. And typically you would just save that on the USB drive. I'm just going to save it on the desktop right now. It does give you a little pop-up of the G code. At this level of training, we're not going to worry about reading all the details of the G code, but here it is. There's not a lot there because all we're doing is the drilling and the contouring. All right, that's it.